Hi, we're going to take a look in this video at how to use the cast diagram. That's what we've got on the screen here. As you can see, the cast diagram is this business of all sine, tan, cos. And we also have another representation of that diagram where we've got the basic angle, and then in the second quadrant it's 180 minus the basic angle, 60 minus theta. So that's the rules that we use in each of the four quadrants. Now, to get a proper understanding of how this cast diagram works, we really need to refer to the actual graphs for the different trigonometric functions, and in this case we're looking at the sine graph. You can do the same sort of thing as we're doing in this video with the cosine graph and with the tangent graph as well, but we're just going to look at the sine graph for this particular problem. Now let's see what the problem actually is. We're actually trying to solve sine theta equal to minus 0.5. We're trying to find the solutions to that satisfy the range 0 to 360 degrees. So how many solutions are there of sine theta equals minus 0.5 in the range 0 to 360 degrees? Well, first of all, we can put onto the graph the actual value minus 0.5, and here it is here. And you can see I've put it roughly somewhere between 0 and minus 1. Now, whether it's exactly halfway down or not doesn't really matter a great deal, because when we draw in the line, what we're interested in is seeing how many solutions that we've got. Now, you'll notice that the line runs all the way along here, and we're way above 180 degrees before it intercepts this graph. That's the first solution to the problem, and you can see that we can draw a line up to the x-axis or the angle axis in order to find out what the solution is. And you'll notice that we've got another solution right there, just underneath 360 degrees. So that's our two solutions. Notice if we refer back to the cast, sine is positive in the first and second quadrants, and we can see that on the graph here. It's positive, you know, it's up above the x-axis or the angle axis, and the same in the second quadrant up to 180 degrees. It's only when we get into the third and fourth quadrant that it goes negative. And there we are, we've got two negative solutions to this problem, and we'll see what those are in a little moment. Now, when we're actually trying to find out what these angles are, we always go with the basic angle with the theta. So rather than trying to do minus 0.5 in the calculator, we would use 0.5. And you can do that in the calculator. You can find out theta by doing sine to the minus 1 of 0.5, and it gives us a value of 30 degrees. Notice that a half, or 0.5, is an exact value. It's one of these ones that you should eventually know off by heart, so that if you see sine to the minus 1 of 0.5, you automatically know it's going to be 30 degrees. So our basic angle is 30 degrees. This is what we're going to add on and subtract off in order to find these two angles that appear on the graph here. Let's see what the first of these is. First is 180 plus 30, which gives us 210 degrees. So over on the graph you'll see that that is this here. We've added 30 degrees on. That's what the little arrow here is showing. That's our 30 degrees getting added on to 180 to give us 210. And it shouldn't be too much of a surprise that in order to find the second angle, it's 360 minus theta, or 360 minus 30 in this case. And we can see that if we look at that on the graph, we're going down 30 degrees from the 360. Notice how symmetrical this is. We've got 30 up and 30 down. You can see that symmetry as you look. It's exactly the same distance up here as it is down there. Now, to further emphasize that, let's have a look at what we did when we did the sine theta equal to 0.5 here. Drawing that along, you'll see that we've got two solutions to that, one right here and one right there, both of them positive, and that corresponds to our cast diagram. Everything's positive in the first quadrant, and sine is positive in the second quadrant. You can see that sine is positive in this quadrant here. All these values are above 0. Let's have a look at where this actual angle is. It's at exactly the same distance out, this 30 degrees that we worked out here. So you'll see that that 30 is being repeated all the way along here. And if we wanted, we could have worked out what the other value is for this intercept here. That would be 180 minus 0. 180 minus 30 would give us 150 degrees. So all in all, we have four different solutions. If we had sine theta equal to minus 0.5, we've got the two solutions that we've found, the 210 and 330. But if we had sine theta equal to 0.5, we'd have two solutions as well, which would be 30 and 150. I hope that helps you understand this a little better. When you're doing problems involving sine theta equal to something or other, or cos theta equal to something or other, you need to draw the actual diagram of the wave function, the shape of the curve, as you can see here, as we've done for sine. But you need to do the same thing if you're doing it for cosine, and a similar sort of thing if you're doing it for the tangent graph. That helps you understand what's going on with the whole cast diagram. I don't think you can really understand these sort of things just separate from each other. So hopefully that helps, and look out for other videos on a similar sort of theme to this. That's all for now. Thank you for listening, and bye.